let's talk about something you probably look through, drink from, and tap on every single day without a second thought. I'm talking about glass. It seems so simple, right? But behind every window, every bottle, every smartphone screen, there's this incredible story of science, fire, and a little bit of magic, all starting from, well, basically just a pile of sand. Let's dive in. So to get started, I've got a riddle for you. What's something that's hard enough to build skyscrapers with, but fragile enough to shatter in an instant? It's perfectly see-through, but technically, it's a liquid. You got it. The answer is glass. And it's these contradictions that make its story so fascinating. So how in the world can something be a solid and a liquid at the same time? It sounds impossible, but to solve this riddle, we have to zoom way, way in. I mean, down to the level of individual atoms. That's where the secret is hiding. Okay, so in a normal solid, like a diamond or a metal, all the atoms line up in a perfect, repeating crystalline structure. Think of soldiers in formation. But glass is totally different. It's what scientists call an amorphous solid. When you melt the ingredients and then cool them down really, really fast, the atoms just don't have time to get organized. They get frozen in place, all jumbled and chaotic, exactly like the atoms in a liquid. So that's the big secret. Glass is basically a liquid that's been stopped in its tracks. It's a frozen liquid. So we know what glass is, atomically speaking, but what's it actually made of? Well, it turns out the recipe for most of the glass we use every day is surprisingly simple, and it really comes down to just three main ingredients. Most of the glass out there is called soda-lime glass, and it all begins with sand, or silica scientifically. That's the main building block. The problem is sand has a crazy high melting point, way too high to be practical. That's where ingredient number 2, soda ash, comes into play. It acts as something called a flux, which basically just lowers the melting point down to a manageable temperature. But that creates a new problem. This new glass would actually dissolve in water. Not very useful. So we add ingredient number 3, limestone. It's the stabilizer that makes the final product strong, durable, and, waterproof. And this is where the real fun begins. Once you have that basic recipe, you can start adding tiny amounts of other things to completely change the final product. A little bit of iron, which is often in the sand to begin with, gives you that classic green bottle color. Add a pinch of cobalt and you get a beautiful deep blue. Selenium gives you a vibrant red, and if you add boron, you create borosilicate glass, which you probably know as Pyrex. That's what gives it that amazing ability to go from hot to cold without shattering. All right, so we've got our recipe all mixed together. Now it's time for the really dramatic part, turning that powdery mix into a glowing molten liquid that you can actually shape. And this all happens inside these absolutely massive industrial furnaces. I mean, some of these things run 24 hours a day, 7 days a week, for over a decade without ever shutting down. Inside, the temperatures hit a blistering 1600 degrees Celsius, or 2900 Fahrenheit, transforming that powder into this thick, glowing, almost honey-like liquid. So how do you turn that molten goo into something like a bottle? Well, in a modern factory, it's this incredible high-speed mechanical dance. A perfectly measured chunk of molten glass, which is actually called a gob, gets dropped into a mold. A plunger comes down to make a basic preform, and then that piece is instantly flipped over into the final mold, where a blast of air blows it into its final shape. This whole thing happens in seconds, letting factories pump out millions of bottles a day. But making a bottle is one thing. How do you get those perfectly flawless sheets of glass for our windows? For that, they use a truly brilliant method called the float process. They pour the molten glass directly onto a huge, shallow bath of molten tin. Now, because the glass is lighter than the tin, it just floats on top, spreading out into this perfectly smooth, perfectly uniform ribbon. It's an incredible piece of engineering that gives us all the flat glass we see around us. Now, we've made our glass, but let's be honest, in its raw state, it's pretty fragile. So before it's ready to be used in our cars, our homes, or our phones, it needs to be seriously engineered to be much, much tougher and safer. You actually see two main types of safety glass all the time. Your car's side windows and the shower door in your bathroom? That's tempered glass. It's been reheated and then cooled really fast, which creates a ton of stress inside the glass, making it way stronger. But the key thing is, if it breaks, it shatters into thousands of little dull, pebble-like pieces instead of sharp daggers. Now, your car's windshield is different. That's laminated glass. It's basically a plastic sandwich with a layer of clear plastic fused between two sheets of glass. If it cracks, that plastic interlayer holds all the sharp pieces together, like a spider web, so they don't fly into the car.
And the screen you might be watching this on right now, that's on a whole other level. It's chemically strengthened. They take the glass and dip it into a hot bath of potassium salt. In this bath, the smaller sodium ions in the glass get swapped out for larger potassium ions. These bigger ions get crammed into the surface, creating the super dense, highly compressed layer that's incredibly resistant to scratches and cracks.
We've seen how glass is made, shaped, and strengthened. But one of the most remarkable parts of its story is what happens at the end of its life. Because for glass, it isn't really an end at all. It's more like the start of a never-ending loop. Here's the magic of it. Unlike plastic or paper, which loses quality every time you recycle it, glass is 100% and infinitely recyclable. When you melt it down, its messy atomic structure just completely resets. It doesn't remember what it was before. This means recycled glass is every bit as pure and strong as glass made from virgin raw materials. A glass bottle can become a new glass bottle over and over and over again, forever. And this isn't just some nice idea. It's a huge part of the industry. In a lot of places, new glass containers are made with a massive amount of recycled material. We're talking up to 70% of the new bottle being made from old crushed-up glass, which is called cullet. That's a huge number. And using all that cullet isn't just about keeping glass out of landfills, it's a massive energy saver. See, as this chart shows, that crushed recycled glass melts at a much lower temperature than the raw ingredients, like sand. That means the furnaces don't have to work as hard, which saves a ton of fuel and seriously cuts down on emissions. Now, here's a really important thing to know. Not all glass is created equal when it comes to recycling. Your standard glass bottles and food jars? Perfect. Throw them in the bin. But things like Pyrex, window glass, or ceramic mugs have different chemicals and different melting points. If those get mixed in with the bottle glass, they can contaminate the entire batch and ruin it. So what happens to all that glass that can't be turned back into bottles? Well, the good news is it usually doesn't go to waste. It often gets crushed up and finds a second life in all kinds of other things, as an aggregate in construction, as an abrasive for sandblasting, or it even gets mixed into asphalt to make sparkling roads. So when you think about it, it's pretty amazing. From a simple handful of sand, we get this incredible material that's both ancient and futuristic. It protects us in our cars, connects us through fiber optic cables, and holds our food. And its most amazing trick might be that it can be endlessly reborn. The story of glass is a perfect circle. And with new things on the horizon like flexible glass and even bioactive glass that can help our bones heal, the only real question is, what will this amazing frozen liquid do for us next?